This is a video about rational exponents. However, before we tackle rational exponents, we need to take a look at some background information first. Our first piece of background information will be about finding the nth root of a number. And if the term nth root sounds really weird to you, don't worry, I will explain it in 1 second. We'll start though with something that should be familiar, the square root of 64. So that's the number 64 under what's called a radical sign. And hopefully what you remember is that the square root stands for the number that, when you multiply it by itself, will give you the number under the radical. So, since 8 times 8 equals 64, so when you multiply 8 by itself, you get 64, that means that the square root of 64 equals 8. Square roots are also called second roots because when you multiply 8 together, you're multiplying it together twice. It's also possible to calculate roots that are higher than 2. In our 4 new examples, you see numbers under radicals, but there's a little number in the bend of the radical, 3, 4, 5, 6. What these mean is that instead of doing the square root, we're going to do the third root, the fourth root, the fifth root, the sixth root. Up here, when there wasn't a number in the 64, there really should be a 2 there. But when you see a blank inside the bend in the radical, you always assume that's 2. This little number that tells you what root it is called the index. So when we do roots that aren't 2, here's what we have to think. If we attack the third root of 125, instead of asking ourselves what number multiplied together twice will give us 64, we have to think what number multiplied together 3 times will give you 125. You have to kind of use trial and error. And if you think about it, 125 is really the same thing as 5 times 5, which is 25, times 5 again. And so your clue is that it needs to be the same number multiplied together a bunch of times. So this is going to be our answer. We would write that the cube root of 125 equals 5 because 5 times 5 times 5 equals 125. When we do the fourth root of 81, we would need to think of what number multiplied by itself 4 times would give you 81. And again, this is trial and error. You've got to try some things out. And what it turns out is that 81 is 3 times 3 times 3 times 3. So your answer would be 3 because 3 multiplied together 4 times gives you 81. When you do 32, you need to come up with a number that when you multiply it together 5 times gives you 32. And if you think about what number to the fifth would give you 32, that happens to be 2. So since you could rewrite this as 2 times 2 times 2 times 2 times another 2, our answer would just be 2, because 2 is the number that when you multiply it together 5 times, you get 32. And then finally, in the last one, what number times itself 6 times will give you 1? Well, that answer is 1. So what we just did was we found the nth root. The nth root just means any root. The square root, the third root, the fourth root, the fifth root, the sixth root. It doesn't matter what root you do. You just need to find the number that multiplied together the number of times that it says in the index gives you the number under the radical sign. Now we're going to move from radicals to the topic of this video, exponents. So here's a rule about the relationship between radicals and exponents. A number raised to the 1 over n power is equal to the nth root of that number. So here's what this means. If you have x raised to the 1 over n, that means that that's the same thing as doing the nth root of x. So if I do my little example down below, if I have 64 raised to the 1/6, that means that that is equivalent to the 6th root of 64 plus the square root of 25. And I'm not going to write the 2 because remember when you do the square root, you can assume that that's 2 when it's blank. So if I'm trying to figure out what the sixth root of 64 is, I happen to know that 2 to the sixth power is 64. So that means that the sixth root of 64 is 2. And I know that 5 squared is 25. So that means that the square root of 25 is 5. So my answer here is 2 plus 5, which equals 7. Now it's time for the main course of our video. You can think of all of that as the appetizer. Finally, we have come to rational exponents. And so rational is just another word for fractional. So we're going to be looking at exponents that are fractions rather than integers. So here's your rule. This is the thing that you have to know. A number raised to the m over n power is equal to the nth root of that number raised to the mth power. So that might sound confusing, but write that down, and then we're going to show you what that means. This is what that looks like. I'm going to look at 2 ways to use it. 8 to the 2/3 you could think of as 8 to the 1/3 times 2. And that's just because when you multiply 1/3 times 2, you get 2/3. So I just wrote that in a different way. Now, you guys know a rule about raising exponents to a power that says you multiply them. So if we did that in the reverse, you could say that this was 8 to the 1/3 raised to the second power. So basically I used that power rule backwards. I undid it. I undid the multiplication and broke it up. And we know that 8 to the 1/3 is the same thing as the cube root of 8, and that's all in parentheses being squared. And now what we see is our little rule in action. 8 to the 2/3, that 3 became the root, because I said the n on the bottom, that becomes the root, and the 2 that was on the top becomes the power. That the number that when you multiply it by itself 3 times you get 8, that is 2, and then you would raise that to the second power. This would come out to 4. So 8 to the 2/3 power. Now you could also do this a slightly different way. You could write this as 8 to the 2 times 1/3. So that's still 2/3 is 2 times 1/3. But then what I would do, I would make it 8 squared on the inside and then 1/3 on the outside. So what I'd be doing there is I would make it the cube root because it was 1/3, and I would do 64 on the inside. And since I know that 64 is 4 to the third, I could say that my answer, the cube root of 64, would be 4, because when you multiply 4 by itself 3 times, you get 64. So no matter which way I do it, you get the same answer, which you should. 8 to the 2/3 is definitely 4. But you can think of it as putting the root on the inside, like I did here, or on the outside, like I did here. So the 2 and the 1/3 can switch places, inside or outside. But the main thing you want to remember is that the number on the top becomes a power. So that's saying you're going to square something. And the number on the bottom becomes. The first way that I did it, I put the root inside and the power outside. But you can also do it the way that I did it here, with the power inside and the root outside. However, unless for some reason we have to do it this second way, this is the way with the root inside and the power outside that is usually easiest. And that's what we're about to do in a couple of problems. So if we do these problems with simplifying these bases raised to rational or fractional exponents, and we look at 100 to the 3/2 power, we have to remember that the number on the top of the fraction is the power, and the number on the bottom of the fraction is the root. And we need to think about having 100, and we're going to do one thing on the inside and one thing on the outside. So I said a little bit earlier that it's easiest to do the root inside and the power outside. So when I say put the power outside my parentheses, I'm going to cube. And inside, I'm going to do the square root of 100. So I could have not written the 2, but I will. So the square root of 100 is 10, because 10 times 10 is 100. And then I'm going to take that and I'm going to cube it. And 10 cubed is 1,000. And so that's my answer, 1,000. When I do 32 to the 4/5 power, I'm going to put, again, my power outside and my root inside. And that's the way that you almost always want to do it. You pretty much can't go wrong if you do it this way. So I'm going to do the 5th root of 32 inside the parentheses, and then I'm going to raise that all to the 4th power. And since 32 is 2 to the 5th, which is something that you need to become familiar with, inside my parentheses, I should have a 2. And then I am going to raise that to the 4th power. When you multiply 2 by itself 4 times, you get 16. So by taking the 5th root of 32 and then raising it to the 4th power, you get 16, which is our final answer. The last thing we're going to do is use rational exponents to simplify expressions with variables in them. So in number 8, we have the cube root of x to the 9th, y to the 6th. And to simplify that, what we're going to do is to change the cube root or the third root into a rational exponent. So you need to remember that cube root equals the 1/3 power. So we could really write this as in parentheses x to the 9th, y to the 6th, all raised to the 1/3. And then we know a property of exponents that say when you raise something to a power with exponents in it, you're going to multiply the exponents. So that means you would have x to the 9 times 1/3 and y to the 6 times 1/3. So 9 times 1/3 is x to the 3. 6 times 1/3 is y to the 2. So our answer is x to the 3rd, y to the 2nd. We're going to take the same tactic with number 9. We don't need to do anything to the first parentheses just yet because there aren't any radicals to change into exponents. So I'm just going to rewrite x squared, y to the half, all to the 4th. But I'm going to change the y cubed under the cube root to y to the 3rd to the 1/3 power. So now to simplify, I need to do my powers. So I need to multiply my exponents. So in my first parentheses, I'm going to have x to the 8th because I had 2 times 4. And then y to the 2 because 1/2 times 4 is 2. And in my second parentheses, I'm going to have y to the 1 because 3 times 1/3 is 1. Next, I should have said powers. So I put the 4 in here, the 4 in here, and the 1/3 in here. Now I'm going to multiply. So when we multiply, we add the exponents on like bases. So there's no other x's, just the x to the 8th, so I'll leave that. And then I have y to the 2 plus 1, so y to the 3rd. And now you've seen rational exponents used with numbers and variables.